I am going to show you today by testing acids and base, like how they will be responding to what color changes are seen when an acid or a base is tested. So let us first talk about only your common indicators. Now here are your common indicators. You can see the first one that you see is what is blue litmus, and I told you usually you people know litmus as a paper. So here is the paper. This is what the litmus paper is. So inside this is what you have the paper. So I can show you a little later like how a paper look like. But the real litmus actually is this one, blue litmus. As you can see, a blue solution is what you can see inside. So this is what is litmus blue. We call it litmus blue. Now if I am keeping this aside, then the next one that you have is here. It is here. This is what is litmus lit. It is a solution. Inside you have a red color solution, but then again in the form of a paper. Here you have the litmus paper. So this is the packet of litmus paper. So I am going to open it and show you actually how it looks like. Then the third one is your methyl orange. Here it is. This is a methyl orange bottle. You can see inside the bottle it is an orange color liquid. This is what is an orange. The color may not be visible because the bottle itself is colored, so because of which you will not be able to see the color of the solution or color of the indicator properly. But later on when I take it out in the test, you will see how it look like or why it is called methyl orange. Then the next common indicator is here, next one, which is phenolphthalein solution. So here phenolphthalein solution is a colorless solution. You can see a colorless solution. So inside the bottle you have a colorless solution, and you know it will change to a particular color as we discuss. Alright, now before I go on to do the practical, I should tell you that here blue litmus will turn red if it is acidic solution, or if you want to test with the paper, then again you know blue paper will turn into red. Similarly, red litmus will turn to blue in basic solution. So there it is, or if you want you can use the paper. Methyl orange, you will change into two different colors. So orange, since it is orange in color, so this orange color will turn either to yellow or it will turn to pink. So methyl orange will turn pink if it is acid, and it will turn yellow if it is base. I am going to show you now. Methyl orange is that color. So that means next, if you go on to phenolphthalein, in phenolphthalein, as it is colorless, it will remain colorless if it is acidic. But if it is basic, so if it is basic, then phenolphthalein will turn to pink. Now we will see, by the way, these common indicators, three common indicators will only indicate whether a given solution is acidic or basic. It will not tell you how acidic or how basic. To say how acidic or how basic, we also discuss about universal indicator. So let me show you, later on I will show you the use also. Here it is. This is the paper. We have only the paper, we don't have the solution. This is the universal pH. In fact, universal pH is from 0 to 14, but the paper that we have in our lab has a pH value which can only measure it from 1 to 11. But usually in the laboratories and all, you will have from 0 to 14. So you can see this is what is the pH paper I was talking about. That pH paper also I will show you actually how it looks like from the inside. Then let us see now the test of acid or base by using this three common indicator. Yeah, now you can see there are 6 test tubes here. In the first test tube that you see, this one is the blue litmus solution. The second one is the red litmus solution. Now you may not agree with me that is red, now is very faint red. So it is a red litmus. Then next 2 test tubes, both of these test tubes contain the same solution, and both of these are methyl orange. So as you can see, orange in color. So both of these are orange in color. And why have I put in 2 test tubes? Because one I want to test acid, the other one I want to test base, and you will see what color changes will take place in both of these. Then in both these test tubes I have added phenolphthalein. So because one I am going to test with acid, the other one I am going to test with base. Now you see the original color, these are the original colors. Now since I am going to add drop by drop the 2 acid, now you can see the 2 acid which I am going to use. One acid is one is an acid, the other one is a base, and one is dilute hydrochloric acid. You can use any acid you like. So I would prefer to use dilute hydrochloric acid, and the other one I am going to use is ammonium hydroxide. So let us see what color change. Now see again for the last time, see what the color looks like. See blue litmus, red litmus, methyl orange, both of these are methyl orange, and both of these are phenolphthalein. Now we will see what changes will take place in the color of this when I will be adding acid and base. Okay, since this one is a blue litmus, so I am going to add in this, blue litmus will turn to red if we add acid. So here it is. Let me take a dilute hydrochloric acid. So I am going to add, in fact, take dilute hydrochloric acid. Here it is, here dilute hydrochloric acid. So I am going to take this dilute hydrochloric acid in the dropper. So there it is. So let's see what changes do you notice when you are adding a dilute hydrochloric acid to, you can see now I am adding to this, you can see the color blue litmus. Now let's see whether you see any change in the color taking place when I am adding. So now you can see the blue litmus solution now has turned to red. You can see it has turned red. So since initially it was blue in color, so a blue litmus turns red. So when you are adding an acid, so in an acidic solution, a blue litmus turns red. Again, for the last time, see it very nicely, see how red it has become. So it was very dark blue before, but now it has become red. So a blue litmus turns red when an acid is added to it. So okay, let me keep this aside here. Now I am going on to next. Here is the red litmus. So I want to test this red litmus with base. Here it is. I am taking this base. I am going to take ammonium hydroxide. So with the dropper, let me add ammonium hydroxide and let's see what happens. Now see the color change that will be noticed there. See very carefully now. There I am adding. So now just a few drops, 2-3 drops is what I have added. So just by addition of the 2-3 drops only, now see how the color change. And if I shake it, now the whole solution is what is turning to blue. Now, so this one was a blue litmus turning to red and a red litmus turning to blue. So now very nice blue is what it has turned to. Now if you see it again carefully. Now I showed you just now with the solution, but then we also discussed about the paper. So let's see about the paper. So here is the litmus paper which I was talking about. So this is the whole bundle of your paper, blue litmus paper. So let me take one strip. If I take one strip and test with the acid, let's see what happens. Here I am taking the same acid now, dilute hydrochloric acid. Now notice what changes in color is noticed with this litmus. See, I am adding this. So you can see that the color of the litmus has turned to red. So blue litmus turns red. So this is for convenience we use a paper. Actually you know that litmus actually is a solution, but for convenience purpose only is what we are using the paper. So you can see how nicely it has turned the color. So this is what has turned to red. Okay, now let's go to the next paper. So I am going to take now the red paper. You can see red litmus. This is red litmus paper. So if I am taking the red litmus paper here, now this red litmus paper, nothing will happen if I am adding an acid here, because red litmus will turn to blue when it is basic solution. So that means basic solution means now if I am using again ammonium hydroxide, here is ammonium hydroxide. If I am using this ammonium hydroxide, now you will see how the color will change. So here, let me add here drop wise. Here, see this. See how the litmus actually has turned its color to blue. So it was a red litmus, but then the red litmus has turned blue. So you can see how nice color blue it has turned to. So this is how the paper actually works. So I have shown you both the solution as well as the paper in terms of the litmus, that is in terms of your red litmus and blue litmus. Now let's go to methyl orange. Here I have 2 test tubes of methyl orange. So let me test the first methyl orange with acid. And do not forget, in an acid you can see it is orange in color. Again let me autofocus it. Yes, it is orange in color. Now you will see that the orange color will turn to pink in one case, it will turn to pink in acid, and it will turn to yellow in base. Let's see now. I am going to add now dilute hydrochloric acid. Here it is. Now if I am adding dilute hydrochloric acid, now you can see it has changed the color. So the color change which has taken place has slightly become different from what it was before. Previously it was yellow. Now you know it has slightly become pink in color. So let me autofocus it. Slightly pink in color. So this is how your methyl orange turns to pink in acidic solution. Now let me test now this methyl orange with base. Let's see what happens with base. With base it must turn yellow. So if I am adding now ammonium hydroxide, so it is very difficult to distinguish yellow, pink and this one, but you can see the color change is what is taking place. So now it has somewhat become yellowish in color even though not much changes is what you should notice. So as I said, to distinguish pink, yellow and orange becomes a little difficult, but then nevertheless now there had been some color changes. Now let me show you. Now you may say, sir, all three colors were the same. So to show you actually that there has been some color differences, let me take the other one. You can see here the two. So there it is, the two of them. So there is definitely a color difference, as you can see, between the two test tube. One I had tested with acid, so and the other one is what I had tested with base. So one is what will take it as yellow and the other one is what will take it as pink. So that was methyl orange. Now let me take these two test tube. Both this test tube contains phenolphthalein. Now you can see phenolphthalein is colorless, it looks like water. Now I am going to test this with acid as well as base. Now let me put base in the first one. First let me test with acid. You know, methyl orange will not change its color if you are adding an acid. So in the first test tube I am putting an acid. You can see now whether if any color change is taking place in the first one. You can notice that there has been no change in the color taking place in the first one. So you can see, even though so much of acid is what I have added here in the first test tube, there has been no change in color. So that's why your phenolphthalein remains colorless in the acidic medium. It remains colorless in the acidic medium. Now in the second test tube, which contains less amount, as you can see, very small amount of phenolphthalein, the first test tube has become larger in volume because of the fact that I added their dilute hydrochloric acid. Now in the second one, let me add now ammonium hydroxide. I am going to add ammonium hydroxide in the second test tube. In the second test tube, if I am adding ammonium hydroxide, now see the change in the color that you notice. See there, a very nice color is what has come out. So there you are. So phenolphthalein will turn to pink when you are using a base. Phenolphthalein turns pink in a basic solution. Yeah, now let's do the test with the universal indicator. You can test as many solutions as possible, but then you can see in front of you I have taken 5 different solutions. The first one is this one is what is your sodium hydroxide. The second one is your ammonium hydroxide. Both of these are bases. Then next one is what is dilute sulfuric acid. Then we have dilute hydrochloric acid, and finally we have concentrated sulfuric acid. This is concentrated sulfuric acid. This is dilute hydrochloric acid. This one is also dilute sulfuric acid. Then here from this strip, the cover which I had shown you here, this is what is the cover of your universal indicator. So I had already taken out this one. So here is the indicator, you can see. So these are the strips of paper. Let me peel it off. So then I am going to use one of the booklet. So here, this booklet is what I am going to use. So here it is. So you can see this is what is a universal indicator. Now it has many strips. So here it is. Now last time when I was teaching you theory, I was telling you about this strip, and then by the way, it is neither red litmus nor it is blue litmus. So it is your universal indicator. This is a universal indicator containing you can see many strips of papers are there here. Now then by looking at the color change of this paper only, you should find out what the pH value is. Now just it will take a little time to dry it up, but then let me tell you how to compare the pH. So I was talking about a paper, different color paper. You can see since this indicator will only give you pH from 1 to 11. So that's why you can see the number 1 has a different color, 2 is different color, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this color is what actually comes with the packet only. You can see it came with the packet. So we have to compare the color change with this one, so that immediately you can identify which whichever color the solution has changed to, the paper has changed to, then you can identify the pH value of that. So if less than 7, you know definitely it is acidic, and then but acidic common indicator can tell you only whether it is acid or base. But universal indicator will tell you how much acidic, because the lower the number, the more acidic it is, and higher the number, more basic it is. So now what I am going to do is I am going to test with this strip. So let me go to the basin. I think it will be easy for me to show you. So if I am going to this basin, so there I am going to use these solutions, and in fact I will show you the solutions also. Here let me, since I have 5 solutions, let me take 5 strips. So I am going to peel off 5 strips, and let me keep it here so that we can directly see the color changes. So let me keep one here, second one here, third one here, fourth one here, and fifth one here. So here are the 5 strips, and I am going to test this 5 strip of paper by using different solution. And again I should tell you that since the pH of different solution which I am going to take are different, yeah, the pH of this are different, so we will see the color change also will be different. So I am first starting with sodium hydroxide. Let's see what happens when I am using sodium hydroxide solution. Okay, here just let me use a few drop only. Here it is. So the first universal indicator I have used sodium hydroxide. Now the second paper I am going to drop there ammonium hydroxide. So let's see what happens when I am dropping ammonium hydroxide. Here you are, 1, 2, 3. Ammonium hydroxide. Let me separate the two. So this one is ammonium hydroxide. So since both of them are bases, so that's why the color are matching. In fact, they are very similar color is what you see. Then I am going to go now with the third one, that is here dilute sulfuric acid. Let's see what happens with dilute sulfuric acid. So if I am using dilute sulfuric acid, so here it is in this strip, in the middle of the strip only I am putting dilute sulfuric acid, and let's see what color changes do you notice here. Here it is. This is dilute sulfuric acid. Then the next that we have is dilute hydrochloric acid. Here dilute hydrochloric acid. I am going to now test with dilute hydrochloric acid. So here we go, dilute hydrochloric acid. So color change. This is with dilute hydrochloric acid. And finally with the concentrated sulfuric acid. Now I have to be a little careful with concentrated sulfuric acid, it can be a little dangerous. Here it is, concentrated sulfuric acid. Let's see the changes here. Now since it was the same paper, all papers were the same, but you will notice after some time that the color that has changed, or the color change which has taken place, is what is different. Okay, so let me zoom this a little bit. Now see the color change. So you need to dry it and then compare with this paper. You have to compare the color of this paper. So now see where it is matching, what color it is matching. So that is what is the pH value of that particular solution. So it will take time, so I can't wait long, or else the video will go very very long. So but then you will see that the color is different for different paper, so it is not the same. So again I am repeating, you have to match the color with this paper. So as you match whichever color it is matching with, like for example if I want to match here, I think this is what it is matching, you see number 4, and this paper is what is matching, this one I am talking about, this paper, just look at that 4, and if you look at this one, then it is I think matching 2. So I think this was the most strongest acid I had used, was your concentrated sulfuric acid. Concentrated sulfuric acid, look at this, so this is matching more or less this one. So 1, pH value is 1, means very very strongly acidic. So this one was something which is matching a somewhat greenish, if you can look at this one, greenish, and somewhat if you look at that side, I think I had added acid somewhere here. So I think we should compare that color. I think it is showing something like this, 5, that is also acidic. And if you go to that, that was more towards a bluish side, greenish side, you can see, you can match like this. So those were 2 bases. So this were bases, and this is how actually we use the indicator, the universal indicator, to detect the pH value of different solution. So that was about the chapter acid, base and salt.